All right, good afternoon, Algebra 1. It's Mr. Walker. It's been a while. How y'all doing? So what we got today is just a little bit of a review of some things that you've seen before, because it's been a while. So we've got a couple equations. These are all two-step equations that we're doing today. And number 1 and number 2 are instances where you will need to eventually multiply in order to solve for your variable. So what I mean by that is I'm wanting to get this fraction by itself first before I multiply, which means I got to deal with that 1, So in order to deal with that 1, I need to do the opposite of what I see. Here it's a positive 1. So I need to subtract 1 from both sides. So we got v over 3 equals negative 2 minus 1 will get you negative 3. Use a calculator if you need help. Now I need to get v by itself, which means I need to multiply now. I need to multiply by what I see in the denominator, the bottom of the fraction. It's 3. So I multiply both sides by 3 because, again, what I do to one side, I have to do to the other. The 3's on the left will cancel each other out. They're gone. So we're left with just v, which is exactly what we want. V equals, now we do negative 3 times 3. Use a calculator. That'll get you negative 9. And so v equals negative 9. That's the answer for number 1. We did it. Let's move on to number 2 now. Same type of deal here. I want to focus on getting this fraction by itself, which means I have to deal with this positive 2 first. In order to deal with it, I got to do the opposite of what I see. I see a positive 2, so the opposite of positive 2 is negative 2. So I'm subtracting 2, minus 2 on both sides. Whenever you do that, these 2's are gone. So we're left with a divided by 2 equals, now do 5 minus 2. Hopefully that's pretty easy. We got 3. Now, just like we did for number 1, we need to multiply by what we see in the bottom of the fraction. So I'm going to multiply both sides by 2. The 2's on the left will cancel. So we're left with just a. So a equals, now we do 3 times 2, and we get 6. And that's a two-step equation where we need to eventually multiply in order to get the answers. Let's move on to slide 2, problems number 3 and 4. This is the opposite. We need to divide eventually in order to solve for our variable. So I want to focus on eventually getting this by itself, which means I have to focus on that first. Whenever you do that, we need to focus on that negative 6. We need to do the opposite again. So add 6 to both sides. So these 6's go away. Man, this is not writing for me. There we go. Now, that negative, that minus, stays with the 7. Don't forget that. So negative 7x equals, now do 15 plus 6. That's 21. Now, in order to solve for our variable, this time we need to divide by what you see in front of the x. Here I see a negative 7. So we're dividing by negative 7. Those negative 7's on the left cancel, so we're left with x equals 21 divided by negative 7, negative 3. And that is number 3. Now we got to do number 4. Let's use blue. We got negative 4 plus 5r equals negative 74. We're going to follow that exact same process. So I'm going to start but with this negative 4 here. Opposite of negative 4 is plus 4. So I'm going to add 4 to both sides. Negative 4 plus 4, those go away. I see a plus this time, so that means my 5r is positive this time. Equals negative 74 plus 4. Use a calculator, that'll get you negative 70. It's not a very good looking 7. There we go. Step 2, divide by what you see in front of r. Here I see a 5, so we're dividing by 5. The 5's over here cancel. So r equals, this is where you'll need to use a calculator because 70 is kind of a big number. Negative 70 divided by 5 should get you minus 14. And there we go. Again, this was just a little bit of a review. I know I didn't spend a whole lot of time doing this, but if you've got questions, send me an email. Send Mrs. Grunsky an email. We're both more than happy to help you. Also, send Mr. Vetter an email if you want to work with him instead. Otherwise, thank you guys for watching. We'll see you in the next video, okay? See you later.